In this very short video, we're going to expand a little bit more about the all or nothing response. So we've talked about action potentials, resting potentials, how the action potential propagates along the neuron. We've just spoken about the refractory period and how we get this little time delay between action potentials. And we touched on the fact that the threshold level needs to be reached in the relative refractory period in order to get an action potential. Today, we're going to talk about the all or nothing response. And with the all or nothing response, we will only get an action potential if we reach threshold level. So remember, with depolarization, sodium floods in, and as long as we get to this threshold of -55, roughly speaking, you'll get an action potential. But you do have these what we call failed initiations shown here, where even though you have had a little bit of depolarization, it's not been enough to get to threshold, so an action potential was not generated. The other thing with the all or nothing response, so you either get an action potential or you don't get an action potential, but the size of the action potential is always the same. So same size of action potential. So the action potential goes from -70 up to +40 and then back down again. Same size regardless of the stimulus. The only thing that will change, if it's a very big stimulus, you might get the action potentials more closely together. We'll look at this on this image here. So what we're going to have is successive stimuli. So each arrow is a different stimulus on the axon trying to generate an action potential. And the stimuli are of increasing intensity. So each stimulus is bigger stimulus than the stimulus before. And to begin with, the first three stimuli, even though they're increasing in size, we're not getting an action potential. So there's no action potential because we're not getting to threshold. So we're not getting to threshold, we're not getting an action potential. So below this threshold, no action potentials. However, we've got the threshold intensity here, and once the stimulus gets beyond this, we get enough depolarization to get past the threshold level and we get ourselves an action potential. So it's all we have an action potential or nothing, we don't have an action potential. However, if you look at this, each stimulus is bigger than the previous, but the action potential stays exactly the same size. So there's no difference in the size of the action potential. All that will differ is the intensity or the frequency of the action potentials, which you can see on this picture here. So what we have on this image, if there's a very weak stimulus, we're not going to get an action potential. If we get past threshold with a weak stimulus, we get an action potential. If the stimulus is a bit bigger, we'll have action potentials with little pauses in between. If it's a very strong stimulus, you get action potentials very close together, and we're only going to be separated by 1 millisecond, and that 1 millisecond corresponds to the absolute refractory period. And remember, in that period, we absolutely cannot get an action potential because the sodium channels can't open. So the difference between weak and strong stimuli are just the frequency of the action potentials. Just like that. It's just this, the frequency of them. In our last video on the nerve impulse, we're going to be looking at various factors that can affect the speed of conduction. Thank you.